All right, everyone. Good afternoon. It is the 19th. I think that means it's Thursday. Yep, Thursday. Hopefully, you guys are all working on your no reassignment. Um, I do believe that's the one we're going to stick with. I'm not going to be using Alex. I don't want any concerns with if we can or we can't get logged in. I will update you with all of that on Google Classroom. But for right now, there's no reason why not everyone can get into the No-Re account. So we're going to continue to go that way. Some questions that I was asked last evening, and I was able to work them out and get them to the students who were asking about them. There was a proportion question from our no-re homework where we were cross multiplying and we were worrying about whether or not how do we solve when we have something squared. Again, I don't know exactly what options you're given. I can go back and try to take a look and click through those. But one of the things that we have to make sure is that when we are simplifying, that we remember our rules for square roots, which means if I take the square root of our 32 over 9, we've got to make sure that we can separate it. And then make sure that if you can do the square root of 9, that is 3. But when we do the square root of 32, we have to simplify that the way we learned at the beginning of the year with rationalizing. So 32 is 16 times 2, which gives us 4 radical 2. So putting that back in, this may be the answer. If this isn't the answer, you know that you can also give it as a decimal. So that was something that was asked. I know the other one, and again, I posted all of these yesterday as soon as I got done answering the email. I posted it right to Google Classroom so that you had the update. This one was much more extensive, and I am going to first show you the problem. I'm going to zoom in a little bit so you can see the beginning of the problem, and then I'll scroll up and then show you full screen. But again, it is on Google Classroom. This one, we had to cross multiply. And when we do cross multiply, you end up taking 3x times 2x and 3x times 2, and you get this guy, 6x squared plus 6x. When you cross multiply in the other direction, we only end up with 6. Because it's a quadratic, and I know it's a quadratic because there's an x squared and an x, all the terms have to go to the same side. This is an Algebra 1 concept. This is not a geometry thing. It's not something that we learned special in our class. This is something, I get it, we're supposed to have brought back from Algebra 1. So right here is where, if it can't be factored, so into 2 sets of parentheses, we've got to use our quadratic formula. And as I scroll up here, push this up, you guys can see that in red, here's our quadratic formula. I know those of you who had Mr. Snook know the song, but each of the A, the B, and the C come from the parts of our quadratic equation. So A is 6, B is 6, and C is negative 6. So I plugged that in, negative B plus or minus B squared minus 4AC all divided by 2a. And then I just simplified. I have negative 6, 36 comes from the square of 6, and then the negative 4 times the negative 6 times 6 is our positive 144. And then 2 times 6 is 12. I showed, again, all the steps in y. So when I add those together, I get 180, and then copied everything else down. I simplified 180 the same way we did the 32, and this guy ends up being negative 6 plus or minus 6 radical 6 over 12. Now, because the 6 over 12 and this 6 over 12 can reduce using 6's as our common factor, that's why we end up with a negative 1, a 2, and then this invisible 1 that's kind of sitting in front of our radical 5, because 6 over 12 was 1 over 2. When you look at how this answer was given, this is the exact value. If you do it as a decimal, split it into two problems because it says plus or minus. So here's plus or minus. And all I did was put the square root of 5 in my calculator. I could have done the square root of 180 and done 6 plus the square root of 180 over divide all that by 12, or negative 6 minus the square root of 180 divided by 12. The answer I would have gotten here is the same answer I would have gotten down here. This is just all simplified. So again, depending upon how you are expected to answer it in any situation, not just on no-re, that was that. So again, I'll zoom out. That's what the question looked like when it was all done. I don't know what number that was specifically, but I did upload that also to Google Classroom. So with that being said, before we move on for the day, I just want to make sure if anybody else had any questions regarding any of the no-re problems. And if you do, please just comment off to the side. I will answer your questions as quickly as possible. Again, hopefully if there's any specific questions, you have taken a screenshot of it so that I can make sure I know what it is. If not, we are going to start today's lesson. We did already have, I loaded for you the notes that I did this morning from the honors geometry class. I will say that the notes will be very much the same for us. However, we're not going to do as much with proofs as they are. So this is our section 7.3. This is similar triangles. And the theorems. Now, if we were in class, I would tell you to remember that on the side of the side chalkboard, when we did congruent triangles, we had 5 postulates and theorems that we used. And I had them listed on the sideboard by my podium. And I would rattle off all 5 every time. Can anybody tell me, if anybody can tell me any of those theorems or postulates, I'll make a list. So this is from our congruent triangle chapter. If anybody can remember any of the congruent theorems or postulates, that way we can create our list to kind of remember for what we're going to do now. Yay, side, 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 side angle, side, good, side, 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 side angle, side. Anybody else have any other ones? Yay, angle, side, angle. I'm going to leave a space as a hint because there's one more in there that I would typically put in that order. Yep, thank you. Angle, angle, side. So all of these, we were able to make triangles congruent. So we knew that tick marks. So with congruent triangles, tick marks helped. And that's something to think about when we're going to go into our similar triangles. So we're going to switch gears. We are going to talk quickly about our theorems for similar triangles because we've done this a lot with congruent. So our first similar triangle theorem is actually side, 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 similarity. And side, side, side similarity, you have to put the similar symbol after it. If you don't, we're going to assume that you're talking about congruent triangles, and we don't want to confuse the two, so it does have to have the similar symbol after it. And rule says all three pairs of corresponding sides have to be in proportion. And remember, in proportion means that they all reduce to the same fraction. So they all reduce to the same ratio. And we called that in this chapter when we say that they all reduce to the same ratio. Anybody know what that ratio is called when every side reduces to the same thing? We have a special name for it now. When it reduces to the same ratio, what's that special word that we use for it now? It's two words. One that starts with an S, one starts with an F. Be careful. All right, the same ratio, when it all reduces to the same ratio. Scale factor. Donnie, check out who joined us today. Donnie. I was worried about you, my man. I was afraid. There we go. There we go. Scale factor. Who's helping Donnie out? Nice job. That made my day. Look at everybody. Morgan's there. Gretchen's back. Luke, Mr. Webb, Allison. You've been every day, Donnie? That makes me happy. That makes me happy. I see some names all the time, so I'm really happy. Seriously, different profiles. I like to see names. All right, so we have our scale factor that has to be the same. So let's just take a look at a picture. Real simple. You're going to already see, if you have checked in Google Classroom with any of the alerts, that there are a ton of different examples that go with side, side, side. And what we're looking at is to make this really stupid easy. And the biggest dead giveaway with side, side, side is you're going to actually see only sides given. Hey, Daniel. Not gonna lie, it's good to see all your names pop up. I'm not sure. I've toyed with the idea of trying Zoom once a week. This technology thing has me a little overwhelmed, but it was nice to actually talk live where I could hear voices. I'm not sure about seeing y'all, but not sure how that would work. But I don't know. Not sure what you guys think about Zoom. So I'm sure you all know what all that is. I just learned about it this morning at 8 a.m. So, but notice with this picture, now that you all should have it copied, that Zoom is a telemarketing thing where you can do video conferencing with up to 100 people. And you can actually see everybody while you're talking. I don't know, it was a little distorted. Some of the pictures were a little distorted. Granted, it was early and everybody had just woken up. But I don't know, you can talk to each other without having to worry about waiting for the delay. Beth, you don't like Zoom? I don't know if I like it either. It could be an option. I'm not sure. It might be something that we could do once a week as an extra option. I don't know. It's weird. I'm trying to figure out if it's something that I'm comfortable with, because I would hate for anything to be inappropriate I think it would be fun, Gretchen. I really do. I just know that we do have some people that do like to push the limits, and I don't want that to be an issue. I'm still toying with the idea. Miss J and I are talking about it extensively, so we'll see. We'll see. All right, let's get back. In your notes, a big hint that side, side, side similarity might be used. Only side lengths are given, and they're all listed. So it's pretty much, so I figured your family would try it today because I was talking with your mom this morning, Mr. Webb, and it did work okay. And Daniel, thank you. I know that it's understandable. I don't know, I'm leery. I'd love to be able just to talk to you guys normal. I know that sounds, I don't know. This is hard for me. I obviously like to interact with you guys in the classroom. I don't really feel like maybe that's a wrong thing. I don't always feel like I'm the superiority figure and you are the students. I don't know. It's nice just to talk. I feel like it's a normal conversation. So this is weird, which is why there's always the delay. I'm concentrating and I look back. So yeah, I think it might be pretty cool. I think it's some place to think about us doing maybe once a week. So again, if your picture has all the numbers, it's pretty much going to be side, side, side. Your job though with this is you have to match out your proportionality statement. So you need to check as I write this out, I'm going to answer the question that I just saw. There is a way to record, Elizabeth. There is a way to record it and then post it so that if there is something that's missed, you absolutely can still watch it. That way, kind of like this, it's posted and then we don't have to worry. FaceTime, I think that's the issue, is we don't want, at least for us as teachers in 2020, we can't do some of that because of, again, it's 2020. We have to be very careful. That way nothing is inappropriate. And that's why there's still that I'm a little hesitant to say the least, but I think it would be really cool. I really do. So once we notice that we think it's side, 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 so again, we think it's side, 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 we want to match up the proportionality statement. Easiest way, find the longest side, match it with the longest side. Again, using the idea that we did with our triangle inequality, where opposite the largest angle is the longest side and opposite the smallest angle is the shortest side. We're still going to do that. I'm going to work left to right to keep things in order. So BC over YZ would have to equal, I'm going to choose AC next because it's just the next longest, only reason I'm doing it that way, XZ, and then I'm going to pick AB to XY. So we have to worry about our proportionality statement. And then when we fill everything in, 16 to 8, 14 to 7, and 10 to 5 shows us that everything is truly a 2-to-1 scale factor. And because it all shares the same scale factor, this is side, side, side. So, easiest way, again, is check your scale factor. Check to make sure all of the sides reduce to the same amount. And it is side, side, side. So that's one. There are only 3. The next one is almost like side, side, side. A little bit easier. So we're going to look at the next one, which would be side, angle, side similarity. And again, with side, angle, side similarity, you have to put the similar symbol after it because we do have one for congruent triangles. And this says two corresponding pairs of sides must be in proportion, and the included pair of corresponding angles must be congruent. So what we're looking at is now a situation kind of like our side angle side from congruent triangles. So if I look at just another basic diagram, L, M, N, R, S, T, and I tell you that these two angles are congruent. This guy's 12, 8, 15, 10. Now, another big hint is, again, if two sides are given, it's probably going to be side angle side. And again, it's because these are there's only three. So it's not like we're going to have a lot of choices to roll through like we did with congruent. So if two sides are given, we again want to check our proportionality statement. So our proportionality statements are very important, which is why we practice them so long. And we again don't need to guess what matches with what. It should be the longer side matches with the longer side, the shorter side matches with the shorter side. So if I'm looking here, LM is the shorter of these two sides, so it must correspond with SR. And had I flipped this triangle and put the 8 over here and the 10 over here, you would have then matched it differently. So make sure you pay attention to shorter goes with shorter, longer goes with longer. So we end up now with LN over ST. So we do have our proportionality statement. We do plug in and check, do these in fact reduce to the same amount? Reduce by 4s and we're left with 3 over 2. Reduce by 5s, we're left with 3 over 2. So since our scale factor matches, now what we have to check is one more piece. So with side, 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 we were done. But with side, angle, side, we do need one more piece. And I can see that because it's given angle L and angle S, which again are between where the two sides touch at that included angle, the reason they're congruent is it's given. So because we have two requirements now, the triangles are similar by side, angle, side similarity. So our two requirements were met. Now I will very quickly show one more thing that does come up, and it was in a lot of the notes that I've already loaded, but I want to point out that here that's the case, but it is possible that you see something like this, and it's not going to give you the angle. You're going to have to determine how the angles are congruent. So, for instance, if I said this was 10, this was 5, this was 8, this was 4, and that was it, I at least know my hint is that there's two sides given. It's got to probably be side angle side. Again, longer side, LM, would go with the longer side over here, OM. I'm going to check if PM matches with NM. And we end up with 10 to 5 equals 8 to 4. And we end up with 2 to 1 equals 2 to 1. Now, of course, there's going to be lots of different fractions. These are just easiest for me to come up with off the top of my head. So our scale factor matches. But does anybody know where the angles come from? What reasoning I would have behind making my angles congruent? What kind of angles are congruent here that I don't have to tell you? You're supposed to know that they happen in a diagram like this. Yay, thank you, Ms. Potts. So our angle requirement, again, there's more than one angle going on here at M. There's in fact 4. So, yay. A lot of answers are correct. Thank you. LMP would be congruent, so I went LMP. I have to go OMN. OMN. And my reason is that we do have vertical angles are congruent. So it does absolutely not have to be given to you like we did before with the tick marks. It is something that we're supposed to know. So side angle side happens this way. So the last one, so we did side, 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 we did side angle side. The last one is the easiest. It's the easiest to spot. It's the easiest to answer. It's the fastest of all three. And that one is simply angle, angle. And we still need the similar symbol after it because all of our similar theorems need it. And our requirement is 2 pairs of corresponding angles congruent. Apparently I forgot the word of. 2 pairs of corresponding angles congruent. That's it. Now, I am going to list it again. I know it's already in there if you happened to look at the other class's notes. But the question is, how does this work if that's all we have? We need to remember that a triangle is the smallest polygon. So we have a lot of exceptions that happen with triangles. We have to remember that with our triangles, that we do have our triangle inequality theorem. That's going to come into play. Opposite the longest side is the largest angle. Opposite the smallest angle is the shortest side. I am certain that you guys remember me standing in the doorway and us talking about the hinge theorem where we're able to compare 2 triangles. And if one triangle's angle is smaller than the other one's, so we have this comparison where the sides will relate the same way. And we also only need 2 angles because our third angle theorem comes into play where we know if 2 of them are congruent, the third one's going to automatically be congruent. So the reason we only need 2 angles congruent to show similar is because all of these things that come into play with triangles. So let's just look at 2 pictures, and we'll keep this really quick. because I'll do it this way. And the easiest way is you don't see any side lengths. Probably a dead giveaway that they're either not similar or that it's angle-angle. So no side lengths given. Check angle-angle. That's going to be the dead giveaway that you are going to probably end up using angle-angle similarity. And all you have to do with this one, in this problem, angle A is congruent to angle D. Angle B is congruent to angle E, and it's given. So because it was given to us, we can say that, and now we know that we have fulfilled our our angle similarity requirement. I realized I forgot on the other paper, sorry, you didn't do it, put that in as well, because we had fulfilled those requirements. So that's a pretty easy one because everything's given. And now this one, let's talk to me. What kind of angles do you think are going to come into play here? And I'm not going to allow you to say vertical angles. Vertical angles we know are already going to be there, so I'm going to go ahead and I'm going to put those in right away. So I know one of my angles I could list as WXV is congruent to angle ZXY, and those are vertical angles. So you guys already hooked me up with that. But what other kind of angles might come into play here? You can see I put other tick marks in this problem. So what other angles may come into play? Okay, I do have parallel lines. So what kind of angles are going to show up with parallel lines when we cut them with a transversal? You're absolutely right. We have our parallel tick marks. And we got transversals going on in here. So what kind of angles are going to show up with parallel lines cut by a transversal? We're close. They won't be corresponding, but I'm going to do another problem very much just one more picture, and I'm going to talk about corresponding. But why would these be? Opposite side, yes, alternate interior, good. So we would be able to choose either of these pairs. So whether we have our alternate interior angles here, notice the Z shape I'm drawing. We have our alternate interior angles there. So we could have angle W is congruent to angle Z, or we could have listed angle V was congruent to angle Y. Either way, alternate interior angles. And that absolutely. Now we only need two of them, so it really doesn't matter which two of these three you pick, but that would give us angle-angle similarity. But again, there's no side lengths, so it's either going to be similar or not. So I figure for you guys what would be best is if I actually showed you a few questions and let you take a look at how these would be asked, and then we'll be done for the day. So hopefully that works out. Again, I'm going to switch things over here and get started, and then I'll let you ask questions as they come up. So I'll give you a second I'm going to give you a second to copy. So I'm going to give you a second to copy those down, and then we're going to talk about them because it's the directions that are as important as the two examples. So we have this right here and this one right here. And actually, Morgan, I'm going to add one more down here, only because you made it a point to say something about corresponding. So I just added a third one that we'll get to. Thankfully, it'll be really fast, and it's just so that I can point out where your corresponding angles will come into play and not just alternate interior. All right, so as you're copying, there are a few questions that are up here. It says determine whether the triangles are similar. So that's our first question that we have to answer. It does say if so. If so means we could say no, they're not similar. And we would still have to explain why they're not, but at least we know that it's possible that they're not. Write a similarity statement. Now remember that our similarity statement, here's our second question. That means we're going to take a triangle to a triangle. We need to make sure that we say that they're similar. So triangle similar to triangle using our letters for the names. So talk to me here. For number 1, if you had to take a guess, again, just going on the hints, because I'm not going to give, let's pretend I'm not going to give you anything else. Tomorrow you're in class and I'm going to give you a quiz. I wish we were all in class tomorrow, but let's pretend. Anybody know what number 1 would be if I had to choose whether the triangles were similar? If they are, which one of our theorems does it fit? Is it side, 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 angle, or angle, angle? Yep, I agree, ladies. It is side, angle, side. That's the one we at least think it's going to be. So again, I can tell right away that 42 degrees, I should have put angle A. I don't know why I wrote 42. That angle A is congruent to angle S, so that works. And what I then need to check is my proportionality. So AK is the longer of the two sides. That's going to match with SY. And AJ is our shorter of the two sides, and that's going to match with SW. So what I want to check is 24 over 16 going to be the same. So I'm checking, are they in proportion, as 18 over 12. If I reduce this by 8s, 24 over 16 does reduce to 3 over 2. If I reduce this by 6s, this reduces to 3 over 2. And now they are in proportion. So our angles, that makes me mad, our angles are congruent, that are in between. Our sides are in proportion, so this is a yes, similar, side, angle, side, similarity. So far, I've explained, because that's the third thing that I want to do. All of this is my explanation. Yes, this takes care of number 3, so I'm going to put little 3s next to it so that you can kind of see that that all goes with my explain. Now the only thing I didn't do was write a similarity statement. So the last thing that I want to do is, before I'm done, is I need to write my similarity statement. I can already see that up here I kind of matched correspondence. So if I name this first triangle A, J, K, I need to, how would I list the other triangle? So again, if I named this one A, J, K, how would I list the other triangle? SWY is correct. Thank you. So SWY is correct. We have to make sure we go in the same order. Nice job. Nice job. SWY. So we had A that started with our angle down the shorter side, the non-listed side, the longer side. Started with our angle, shorter, non-listed, longer. Awesome. All right, so let's take a look at number 2 because we're almost done. And here's the issue with number 2. I am going to always suggest that you separate your triangles. If you leave them like this, it's going to be really difficult to look at. So the first thing that I'm going to do is I'm going to separate for my own visual purposes L, N, and M. And I'm going to separate so that we see P, R, and L. And it will make it a lot easier. LN we can see is 10. 8 is here. And then when I look at all the way from L to R, it's 10 and 5, so that's why it's 15. And then PR is 12. So right now when I look at this, it only has 2 sides listed. So it's not going to be side, side, side. It cannot be side, side, side because we don't have 3 sides listed. So that means it's got to be side angle side or angle angle. And it's probably not going to be angle angle if they wasted the time to put the numbers in the picture. So that means I have to find a congruent angle. Can anybody tell me what angle would be congruent in here? And there's a reason that we have that it's allowed to be congruent. And as you're looking at the picture, I will give you one other hint. It may not be one that's useful, but it is still congruent. Yeah, I'm not seeing anybody answering, so I'm trying to watch the timer because I know. Okay, thank you for writing something though, because I know that the delay is difficult. I keep watching the timer to make sure that about 20 seconds goes by. 20 seconds is a long time. There's no right angle in the problem. It does look like there might be down here, but we don't have the tick mark. I am going to tell you this guy right here is a reflexive angle. It's not, we normally look at reflexive sides. So what I'm looking at is we took this big triangle and sitting right on top of this big triangle, it's like I put one right on top of the other. Almost like if I have a big piece of paper and I put another piece of paper right on top, it kind of blends in and makes it look like one piece of paper, even though you physically saw me put one on top. So what I'm doing is I'm kind of laying LMN, that triangle, right on top of a bigger triangle. And when I take them back apart, I can see that I have one little triangle and then another bigger triangle. So we now have this angle L that actually gets included in both triangles. So we have our reflexive that shows up in both. Angle L is congruent to angle L. So we have that. And that is reflexive. So we are allowed to do that. So we do have congruent corresponding angles. So yay. And I want to check, does LN correspond with LR? Again, longer to longer. Does MN correspond with PR, shorter to shorter? And we find out we have 10 over 15, we have 8 over 12, and it does show us that this is 2/3 and this is 2/3. So they check. What's the problem? Because it told me if I use side angle side, I'm allowed to have two sides with their included angle, and it would be side angle side. So what's the issue with number 2? Even though everything works out the same way as it did in number 1, what's the issue with number 2? Okay, we do have two sides, 10 and 15. Thank you, Morgan. We do have 8 and 12. And it does say with side angle side, we need two sides. Look at where our sides were over here. AJ and AK, the angle was at A. Yep, the angle is in the wrong place. So that's why I put these two next to each other. Because even though everything worked out, the angle is in the wrong place. So this is not side angle side similarity. Angle in the wrong spot. Yep, has to be included. So I did those next to each other on purpose because it was side angle side in the first one. It was not in the second one. All right, last question, and I added this because of our discussion with corresponding angles. And right away in number 3, I am really hoping that we can see there are no side lengths given. So it's either going to be angle or not at all. So no side lengths. So it's either going to be angle or not similar. So what we need to take a look at is our parallel lines. And this is where what Morgan had said earlier with corresponding angles, I wanted to make sure we saw it. Corresponding angles, when we have, and I'll highlight it, when you have your parallel lines, don't forget, cut by a transversal, they will be on the same side of the transversal, but where they're going to be in the picture, they're going to be in the same position. So I have corresponding angles right there because my lines are parallel. I also have corresponding angles right here because they're parallel. And just like in the other picture, I do end up with this as my reflexive angle. So they all end up being congruent. I only need to list 2. So what we end up with is a choice. If you think it's easier to just list the 2 that are the corresponding, because you only then need to give one reason, that works. But you have to remember that because this guy is ABE, it has to be listed with 3 letters because it's stuck on another angle. Its shared vertex gives me more than one angle, would be congruent to angle C. Angle AEB is congruent to angle D, and these are corresponding angles. You might find it's easier just to say angle A is congruent to angle A and say that that's because of the reflexive property. The only thing that you need to do is list 2 of them, and it doesn't matter how you list them. Now, I separated number 2 into 2 triangles. It may help you again to separate them into 2 triangles, but do so after, especially in this case, you recognize what your tick marks are. So I already had that tick mark in for reflexive, that one and that one in for the corresponding parts. And then I could put my other triangle in here, and I have A, C, D, and again my reflexive angle and the corresponding ones. That helps when I have to especially give the similarity statement. So up here, we needed to write a similarity statement. In number 2, we couldn't because it wasn't side angle side. Now in this one, I can use the matching to do A, B, E is similar to A, C, D, and I can follow the tick marks to help. Now, that's all I have for today. I am going to list your notes. I'm going to edit the Google Classroom post. I'm going to try to post everything a little earlier for you guys so that if you want, you can work ahead. I am, I think, going to try to see if I can figure out Zoom well enough so that I can use it. If you guys want to do it maybe on Wednesdays instead of a live stream, and then we can live stream. Maybe I'll just post videos. Maybe we'll switch some stuff up so that you guys don't feel like you have to be with me every day. I hope you're not buying anything, Mr. Webb. But the no reassignment, yes, you have to do the no reassignment. I am checking all of that. Some of you are amazing. I know a lot of you are in the class and listed. I am going to have to make phone calls to the students that haven't signed up. And that way I know everybody can do the no reassignment. And some of you are doing an amazing job of finishing those up. I did load a couple more, and I have all those due dates and everything on Google Classroom. Again, you don't ever have to worry about hearing about that on the live feed. How would we turn in our assignments? Well, again, the good part about the no re stuff is I do get to see those grades on my teacher account, so you don't have to worry about turning anything in. If you have late work, Donovan, or if you have corrections, that can always be pictures taken and sent them to me via email. The no re information, I posted the logins a couple times on Google Classroom. You just have to go to the website that was listed and put in your class code. I broke it down by periods. And then honestly, you'll click on the tab that says assignments, and right there it'll take you to what was assigned. And right now, I want to say off the top of my head that you guys only have, and I'm checking, geometry only has 2 assignments listed in no re, 8.1 and 8.3. So you guys only have to worry about 8-1 and 8-3. And yeah, I've logged in. Okay. So yeah, all you have to do is go and click on the assignment, and they give you a video, and then you have to work through it. And I believe it's question by question. I've been told the videos help tremendously so that you can do it a little easier. But yeah, so I at least have gone in and seen that a lot of people have logged in and have signed up, and they're there. So you just click on the assignments and it'll take you there. Oh, good. That's good. I know I've tried a few. It's hard for me to tell because I know how to do the problem. So I'm hoping that the videos seem as clear as I think they seem. So that's good. Any other questions, guys? All right. I know that there's right now, it says only 16 of you, but it's really good to at least be able to chat back and forth. If we do try Zoom, I will let you know. So you guys have a great afternoon. Please stay on track, stay focused, stay safe, stay smart. Give yourself a schedule and stick to it. And I will talk to you all very soon. Have a great day.